स्पेसिफिक रेजिस्टिविटी ਦਾ ਫਾਰਮੂਲਾ ਕੀ ਹੋਇਆ ਕਿਸੇ ਵੀ ਮਟੀਰੀਅਲ ਦੀ ਰੈਜ਼ਿਸਟਿਵਿਟੀ ਕੀ ਆ यूनिट ऑफ रेजिस्टिविटी कई बच्चे एक गलती कर जाते हैं doing some numericals example 11.4 in text question dear all I am Jaswinder Singh and we are discussing chapter electricity in today's lecture I will be discussing resistivity along with resistivity we will discuss some NCERT in-text questions and NCERT solved examples. Let us start the video. Electrical resistivity is also called as specific resistance ਦਾ ਆਪਾਂ ਹੁਣੀ ਫਾਰਮੂਲਾ ਪੜਿਆ resistance equal to rho L over A ਇਹਦੇ ਵਿੱਚ ਜਿਹੜਾ ਇਹ constant ਆਪਾਂ use ਕੀਤਾ this rho is constant of proportionality this constant of proportionality is called resistivity or specific resistance ਇਸ constant ਨੂੰ ਆਪਾਂ resistivity ਕਹਿੰਦੇ ਆ resistivity ਦਾ ਫਾਰਮੂਲਾ ਕੀ ਹੋਇਆ resistance ਦੇ ਫਾਰਮੂਲੇ ਨੂੰ ਜਦੋਂ ਆਪਾਂ ਰੀਅਰੇਂਜ ਕਰਾਂਗੇ we obtain rho is equal to RA upon L. This is the resistivity. Resistivity is the property of material. The material the property. Resistivity ਨੂੰ ਆਪਾਂ ਕਿਸ ਤਰ੍ਹਾਂ define ਕਰਾਂਗੇ? Resistivity ਦਾ formula. If A is 1, A is area of cross section. If area of cross section is 1 meter square, length is 1 meter, then rho becomes equal to R. So what is rho? Resistivity is the resistance. Resistivity किया resistance है किधर resistance? Resistance of a conductor having area of cross section equal to 1 meter square and length 1. इस तरह दा conductor ਇਹਦਾ area of cross section 1 meter square है the length 1 meter है ਉਹਦਾ ਜੋ resistance ਹੋਏਗਾ ਉਹ ਉਸ material ਦੀ resistivity होएगी 1 meter square area 1 meter length so this is 1 meter cube a cube of 1 meter 1 meter length 1 meter breadth 1 meter height ਇਸ ਤਰ੍ਹਾਂ ਦੇ ਕਿਊਬ ਨੂੰ ਆਪਾਂ ਕਵਾਂਗੇ 1 meter cube ਕਿਸੇ ਵੀ ਮਟੀਰੀਅਲ ਦੀ ਰੈਜ਼ਿਸਟਿਵਿਟੀ ਕੀ ਆ ਉਹਦਾ 1 ਮੀਟਰ ਕਿਊਬ ਲੈ ਲਿਆ ਉਹਦਾ 1 ਮੀਟਰ ਕਿਊਬ ਜਿੰਨਾ ਰੈਜ਼ਿਸਟੈਂਸ ਪ੍ਰੋਡਿਊਸ ਕਰੇਗਾ ਜਿੰਨਾ ਰੈਜ਼ਿਸਟੈਂਸ ਆਫਰ ਕਰੇਗਾ ਉਹ ਉਸ ਮਟੀਰੀਅਲ ਦੀ ਰੈਜ਼ਿਸਟਿਵਿਟੀ ਹੋਏਗੀ ਰੈਜ਼ਿਸਟੈਂਸ ਆਫਰਡ ਬਾय 1 ਮੀਟਰ ਕਿਊਬ ਆਫ ਐਨੀ ਮਟੀਰੀਅਲ ਇਜ਼ ਇਟਸ ਰੈਜ਼ਿਸਟਿਵਿਟੀ ਕਾਪਰ ਦੀ ਰੈਜ਼ਿਸਟਿਵਿਟੀ ਫਾਈਂਡ ਕਰਨੀ ਆ ਕਾਪਰ ਦਾ 1 ਮੀਟਰ ਕਿਊਬ ਲੈ ਲਓ ਉਹਦਾ ਰੈਜ਼ਿਸਟੈਂਸ ਫਾਈਂਡ ਕਰ ਲਓ ਉਹ ਕਾਪਰ ਦੀ ਰੈਜ਼ਿਸਟਿਵਿਟੀ ਐਲੂਮੀਨੀਅਮ ਦੀ ਰੈਜ਼ਿਸਟਿਵਿਟੀ ਫਾਈਂਡ ਕਰਨੀ ਆ ਐਲੂਮੀਨੀਅਮ ਦਾ 1 ਮੀਟਰ ਕਿਊਬ ਲੈ ਲਓ ਉਹਦਾ ਰੈਜ਼ਿਸਟੈਂਸ ਫਾਈਂਡ ਕਰ ਲਓ ਉਹਦੀ ਰੈਜ਼ਿਸਟਿਵਿਟੀ so resistivity is the resistance offered by 1 cube meter of any material. It is the property of material. Unit of resistivity, unit we find from its formula rho is equal to RA upon L. Formula to unit find karange. Resistance is 1 ohm, area of cross section is 1 meter square, length is 1 meter. मीटर ना मीटर कट गया 1 ohm meter. तो resistivity ਦੀ यूनिट किया 1 ohm meter. कई बच्चे एक गलती कर जाते हैं ਇਹਨੂੰ ohm per meter ਜਾਂ ਇਸ ਤਰ੍ਹਾਂ ਲਿਖ ਦਿੰਦੇ ਨੇ ਕਿਉਂਕਿ per meter ਲਿਖਣ ਦੀ ਆਦਤ ਪਈ ਹੁੰਦੀ ਹੈ but this is not correct. What is the correct unit? The correct unit is ohm meter. We will not write it ohm per meter because this is correct. We are in habit of writing per meter, but we will not write ohm per meter. The correct unit is ohm meter. So ohm meter is the unit of resistivity or specific resistance. Doing some numericals. How much current will an electric bulb draw from a 220 volt source if the resistance of the filament is 1200? Potential difference is 220 volt, resistance is 1200 ohm. What is required? Current. We have to find current. Formula using Ohm's law, V is equal to IR, I is equal to V upon R. V is 220 volt, resistance is 1200 ohm. 0.18 ampere. Statement: electric bulb will draw a current of 0.18. Much current an electric heat will draw. 20 volts. The resistance of the coil is 100. What is given? Potential difference volt is 100. What is required? We find current. Law I is equal to by R. Potential difference volt 100 ohm per ohm ampere. Statement: electric coil will draw a current. Example 11.4. Potential difference between terminals is 60 volt, draws a current 4 ampere. What current the heater draw if potential difference is 120? What is given? Equal to 60 volt, it is 4 amperes. What current will draw? Find this I1, this need to I2. When potential difference is increased to 120 volt, equal to 120. Before this, we find using Ohm law equal to IR, R is equal to upon I. Find the resistance. पहला पर resistance find करेंगे. ये हो गया 1 पर I1 है तो resistance find कर लिया 60 volt over 4 ampere. This comes out to be ohm. Potential difference is 120 volt, resistance is 15 ohm. We need to find I2. I is equal to over R is 120, R is 15. I is equal to 8 ampere. Current through the heater becomes 8 ampere. Resistance of a metal wire length 1 meter, 26 ohm at 20 degree. If the diameter is 0.3, what will be the resistivity? Predict the material using table 11 point. What is given? L is equal to 1 meter, resistance 26 ohm, diameter is millimeter. So this we need to convert into 10 raised to power 4 meter. Radius. Radius is 0.42 10 raised to power 4 point. Formula: resistance equal to rho L over A. So rho is equal to RA upon L. So what is area of cross section? We are having wire. Area of cross section of wire is circle. Area of circle is pi r square or pi d square by this formula. Rho is equal to RA upon L, R in pi r square over L. Rho is equal 26 ohm, pi resistance is 0.352, 10 raised to 4 whole divided by L. Length is 1 meter. Get putting it to standard form, decimal ਨੂੰ ਆਪਾਂ 1 ਤੇ 1 2 ਪਲੇਸ ਪਿੱਛੇ 1.8365 in 10 raised to the power minus 8 ਪਲੇਸ ਆਪਾਂ ਲੈਫਟ ਵੱਲ ਲੈ ਕੇ ਗਏ ਆ ਤੇ ਇਹਦੇ ਵਿੱਚ ਆਪਾਂ +2 ਕਰ ਦਵਾਂਗੇ। ਇਹ ਬਣ ਜਾਏਗਾ 1.8365 in 10 raised to the power minus 6. This is nearly equal to 1.84 minus 6. ਇਹਨੂੰ ਆਪਾਂ ਕਹਿੰਦੇ ਆ ਰਾਉਂਡਿੰਗ ਆਫ ਕਰਕੇ 1.84. This is the unit ohm meter resistivity. Writing the statement, resistivity of metal is 1.84 into 10 raised to the power minus 6 ohm meter. ਇਹ resistivity ਕਿਸ ਮਟੀਰੀਅਲ ਦੀ ਆ? ਇੱਥੇ ਆਪਾਂ ਟੇਬਲ 'ਚ ਦੇਖ ਰਹੇ ਹਾਂ। This is the resistivity of manganese. Next question, a wire of given material having length 1 meter, area of cross section A, resistance of 4 ohm. What would be the resistance of another wire of same material having L by 2 length and area of cross section 2? Length is L, area of cross section is A, resistance 4 ohm. Another wire, same material having length is L by 2. L by 2, area of cross section is 2A. We need to find what is required resistance of new wire using the formula of resistance. ਇਸ ਤਰ੍ਹਾਂ ਦੇ ਕੁਐਸਚਨਸ ਦੇ ਵਿੱਚ ਆਪਾਂ ਕਿਸ ਤਰ੍ਹਾਂ ਕਰਨਾ ਹੈ, ਜਿਹਦੇ ਵਿੱਚ ਆਪਾਂ ਕੋਈ ਇੱਕ ਫਿਜ਼ੀਕਲ ਕੁਆਂਟੀਟੀ ਡਬਲ ਕਰਤੀ ਜਾਂ ਹਾਫ ਕਰਤੀ, ਉਹ ਆਪਾਂ ਦੇਖਦੇ ਹਾਂ ਕਿਸ ਤਰ੍ਹਾਂ ਕਰਨਾ ਆ। ਪਹਿਲਾਂ ਆਪਾਂ ਫਸਟ ਵਾਇਰ ਦਾ ਰੈਜ਼ਿਸਟੈਂਸ ਫਾਈਂਡ ਕਰ ਲਾਂਗੇ। ਸਾਡੇ ਕੋਲ ਫਾਰਮੂਲਾ ਕੀ ਆ? ਰੈਜ਼ਿਸਟੈਂਸ ਇਜ਼ ਇਕੁਅਲ ਟੂ ਰੋ L over A. R1 is rho L over A. R1 is resistance of first wire. ਆਪਾਂ find ਕਰਨਾ R2, resistance of second wire. R2 is equal to rho, new length is L by 2, area is 2A. R2 is equal to rho L over 2A into 2. ਆਹ ਵਾਲਾ 2 ਥੱਲੇ ਆ ਜਾਏਗਾ, this 2 will come in denominator. R2 is equal to rho L over 4A. ਹੁਣ ਆਪਾਂ ਇਸ ਫਾਰਮੂਲਾ ਦੇ ਵਿੱਚ ਫਸਟ ਫਾਰਮੂਲਾ ਜਿਹੜਾ ਆ ਫਾਈਂਡ ਕਰਾਂਗੇ। ਕਿਸ ਤਰ੍ਹਾਂ? R2 is equal to 1 by 4 L over A. Rho L over A is R1, so we put R2 is equal to 1 by 4 R1. So we get R2 is equal to 1 by 4 R1. This is the equation. New resistance becomes 1 by 4. What was the resistance? R1 is 4 ohm. So the new resistance will become 1 ohm. Writing the statement, the resistance of another wire of the same material having length L by 2 and area of cross section 2 is 1 ohm. So new resistance will become 1 ohm. In text questions, on what factors does the resistance of a conductor depend? We have the formula R is equal to rho L upon A. L is length of the conductor, more is the length, more is the resistance, directly proportional. Second, area of cross section, more is the area of cross section, less is the resistance, inversely. Depends upon temperature. The variation of different materials is different for change in temperature. Nature of material. Different materials have different resistance. Will current flow more easily through a thick wire or a thin wire of same material when connected to same source? Current flows more easily through a thick wire as compared to thin wire of same material when connected to the same source. The reason, Resistance is inversely proportional to area of cross section. Resistance increases with decrease in thickness. Resistance of electrical component remains constant. Potential difference decreases to half. What change will occur in current through it? So from V is decreased to half. What change will occur in its current? From Ohm's law, we know V is equal to IR. V over I is constant. So it means if V is reduced to half, I should also reduce to half to keep the ratio constant. Resistance remains the constant. Resistance is not changing, but potential difference is decreasing to half the values. Potential differences decrease to half. So according to Ohm's law, the current will also decrease to half. The value of current also become half. Why are the coils of electric toaster and irons made up of alloy rather than a pure material? So the resistivity of alloy is generally higher. Number one. Number two, they do not oxidize easily. Alloys do not burn easily. Alloys do not oxidize easily. Alloy जल्दी सड़ते नहीं आ इस करके जिन्ने भी टोस्टर्स इलेक्ट्रिक आयरन हीटिंग इक्विपमेंट्स ਹੁੰਦੇ ਨੇ ਉਹਨਾਂ ਦੇ coils ਜਿਹੜੇ ਨੇ ਉਹ alloys ਦੇ ਬਣਾਏ ਜਾਂਦੇ ਨੇ because they do not oxidize easily. Next question, using table 12.2, answer the following. Which among iron and mercury is better conductor? Iron and mercury. So resistivity of mercury is more. Less is the resistivity, better is the conductor. So iron is better conductor. Which material is best conductor? So the resistivity of silver is the least. So this is the best conductor. Iron is better conductor than mercury because the resistivity of iron is less than that of material. Less is the resistivity, better is the conductor. Silver is the best conductor as its resistivity is the least. This is all about today's video. I hope you have understood all the topics. Any queries you are free to write in comment box. All the queries in comment box will be properly addressed. Thanks for being with me. In my next video, I will be discussing equivalent resistance in series and parallel connection. Don't forget to see that video. Thanks for being with me. Let us revise today's lecture. The resistance offered by a unit conductor of a material is called its resistivity. The SI unit of resistivity is ohm meter. The resistivity of an alloy is generally higher than that of its constituent metals and do not oxidize or burn readily at high temperature. For this reason, alloys are commonly used in electrical heating devices like electric iron, electric toaster, etc. Tungsten is used almost exclusively for filaments of electric bulb because it has high melting point and do not burn easily. Copper and aluminium are generally used for electrical transmission lines because they have low resistivity. Conductor is a component that offer a low resistance. This is all about today's lecture. Thank you for being with me.